Hello class, my name is Reinout Landegem and my partner's name is Pikaso Dutta, and we are going to be giving the Phase 2 update on our project, which is titled SPY and Sector ETF Pattern Recognition Through Clustering and Artificial Neural Networks. Our academic advisor is Dr. Kashana. So for our project, we are going to be studying the volatility as well as the normalized price graphs for the 9 sector ETFs that compose the SPY 500 index. On the right is an image that shows the 9 different ETFs that compose the SPY. We want to identify patterns in the volatility and normalized price graphs using two main methods. The first method we will be using is a time series clustering method, and the second method will utilize artificial neural networks. I will be talking about the time series clustering method, and Pikaso will talk about the artificial neural networks, or ANN. The main question we are going to try and answer for our project is, which of the 9 sector ETFs delegates the SPY volatility and price movement the most? This will allow us to forecast the SPY more accurately while reducing the overall risk while doing so. So the first method that we used, as I mentioned before, is the time series clustering method using R. We used a time series clustering package called DTW-clust. It compares different stocks, or in our case ETFs, and groups them together. After downloading the data off the Bloomberg terminal and converting the data into the proper format, we use this tool to do just that. The image you see on the slide is dividing the 10 ETFs into 3 different clusters based on historical price movements of the ETFs. It is important to note that we had to convert this data to normalized prices. We experimented with changing the amount of clusters, but we feel that 3 different clusters gives us the best results. So from this image, we can pretty much conclude that XLF, or the financial sector ETF, has price movements that are very different from all the other ETFs, which is something that we expected. We can also see that the SPY is most similar to the XLK, which is the tech sector, and the XLE sector, which is the energy sector. All other ETFs fall into the second cluster. So what we can pretty much conclude from this is that if we wanted to predict the SPY future price movements, or normalized price movements rather, and we should pay special attention to the tech sector and energy sector as well.
Now let us discuss on our second part of the project, which is with neural network. So last week we have prepared our input data with technical indicators, where we have considered VIX as our dependent variable and ADX as the independent one. So in data preparation on our test train data, we'll be working with 26961 data points, which we had split in 80-20 ratio. Now we have taken 60 time steps for one output, which means we are training 1 hour of 1 minute data to predict the output, which will be 61st minute, and this will continue on a rolling basis. Now for the RNN setup, we used stacked LSTM with the optimizer as ADAM, and for calculating the loss, we used mean squared error and set the epoch to 30. So the graph below shows our test results, which we have taken just from 60 data points from a subset of 5,000 test data set. And the model took more than 2 hours to get trained, and finally we found that the train loss converts to only 3.6, and the train and test accuracy is below 50%. So from this data we can conclude that the model is not yet good for prediction. So now you see that ADX might not be a good predictor, and hence we are also going to test this model with other predictors or by creating a composite indicator to find the best combination to predict the VIX, and accordingly to increase the training accuracy and the test accuracy.